So we will continue chapter 9 review, which is on chemical quantities. And we've done question 1 only. There were several sub-questions into question 1. And so we were arrived at question 2. And that's similar to question 7 or 8 of your homework on chapter 9. So again, if you struggle with the homework on chapter 9 in question 7 or 8, look at this example to help you see how it can be resolved. So the question is, calculate the number of grams of oxygen required to convert 28.0 grams of propane, propane is C3H8, to carbon dioxide and water. And you're provided the chemical equation there, and it's balanced. And another question will be to calculate the number of grams of CO2 produced. So it's really two questions that are different and that will require different calculations. So we will take the first one first. Calculate the number of grams of oxygen required to convert 28 grams of propane to carbon dioxide and water. So I like to write under the reactant here what we have, and we have 28 grams of propane, and we are looking for the mass of oxygen. And here the 5 coefficient is in red, but the 3 and the 4 here are also coefficients here. But because the question is only focused on propane and oxygen, so we will only focus on this part of the equation. And the roadmap or the concept map will look like this. We will go, it's a gram to gram conversion, right? And that means we will need to go from grams of propane, so those 28 grams here, to moles of propane, because the relationship between propane and oxygen is given in units of moles here. It says here that 1 mole of propane will make 5 moles of oxygen. So this is the only way to convert propane to oxygen. So we need to convert the grams of propane to moles of propane. Then we can change that to moles of oxygen. And the question is asking for grams. So then you need to convert back to grams using the molar mass of oxygen. And oxygen here is O2. So we will need molar masses. The molar mass of C3H8. And here, for the molar mass of C3H8, you take 3 times the molar mass of carbon. By now, I hope you remember carbon is 12.01 grams per mole. And then you add 8 times the molar mass of hydrogen, and hydrogen is 1.01 grams per mole. You add that together, and it's 44.11 grams per mole of C3H8. Again, we are doing an addition, and because we are adding, we pay attention to the least number of decimal places, and both molar masses have 2 decimal places, so we keep 2 decimal places. Another thing is I like to rewrite this molar mass as an equality, mathematically, because this is what we use to write conversion factors. And so I like to see it as an equality. And because we have grams per mole here, it's a complex unit. And the per mole means that 1 mole of propane is equal to 44.11 grams of propane. Let's find the molar mass of oxygen. Oxygen is 16 grams per mole, 16.00, times 2, because there is 2 oxygen per molecule of oxygen. And that's 32.00. Please keep those zeros. They are significant and they matter. Here you are, multiplying, but the 2 is an exact number. So 32.00 is the correct value for the molar mass of oxygen. And again, mathematically, I like to rewrite it like this. 1 mole of oxygen is equal to 32.00 grams of oxygen. Or else write your units fully by specifying moles of what and grams of what. And then the last conversion factor. So these two molar masses will help us do the first conversion and the last conversion. And for the conversion in between here, the mole to mole conversion, we need to use the chemical equation coefficient. And we said earlier, 1 mole of propane will react with 5 moles of oxygen. So mathematically, we write it like this: 1 mole of propane reacts with 5 moles of oxygen. So we have our 3 equalities and we can start the calculation. You always start your calculation with the given amount. And the given amount here is 28.0 grams of C3H8. So start with that, right? That's the given amount here. This is written in the numerator. So the first conversion factor needs to cancel that first unit of grams of propane. So we need the grams of propane here on the bottom. And so that tells us that this molar mass here, we will have the 44.11 grams of propane on the bottom. And that's for 1 mole of propane on top. And this way, the grams of propane cancel. For the second conversion factor, we need to cancel the unit of moles of propane. So moles of propane, we need to have them in the denominator of the second conversion factor. And that second conversion, changes the moles of propane to moles of oxygen. So it's this equality that we will use here. And that's 1 mole of propane is reacting with 5 moles of oxygen. So we need O2 there. Let's format it properly here. O2. Okay, so that's allowing you to change moles of propane to moles of oxygen. And we see how the units of moles of propane cancel. For the next step, we need to cancel the moles of oxygen as a unit, right? So we want them in the denominator so that we can cancel them. And the last step here is changing the moles of oxygen to grams of oxygen using the molar mass of oxygen. So it's for 1 mole of oxygen there, 1 mole. And the mass is 32.00 grams of oxygen. Okay, so in the calculator, you do all numerators together. I like to multiply all numerators together. So 28.0 times 1 times 5 moles of O2 times 32.00 grams of O2. And then you divide by each denominator. And here there is only one denominator worth typing here. It's the 44.11. So divided by 44.11. The calculator answer is 101.56 grams of oxygen. So we need to pay attention to significant figures. And so let's look at this. Every number that comes with the mole is an exact number, right? So those 1 moles, 5 moles are all exact. The molar mass has 3 Sig Figs for the molar mass of oxygen. 4 Sig Figs. 4 Sig Figs for the molar mass of propane. And the given amount has 3 Sig Figs. So 3 Sig Figs is the limiting amount here. So we need to, sorry, this should not be, okay, like this. So 1 and 0 and 1, that's 3 Sig Figs here. What comes after the 1 is a 5. So you need to change the 1 into a 2. And that's grams of O2 again. So that's the mass of oxygen that is required to react with 28 grams of propane. Oops. So that answers the first question. Calculate the number of moles of grams of oxygen required to convert 28 grams of propane. Now we need to calculate the number of grams of CO2 produced from these 28 grams of propane. So let's look at that question again. And we have the question written again here. The mass, the initial mass of propane is given again. And this time what we are looking for is the mass of CO2 produced in grams. So we will need to do a very similar calculation, but this time it's with CO2 instead of oxygen. So the concept map is very similar. You start with grams of propane, change them to moles of propane. From the moles of propane, you use the chemical equation here to change moles of propane to moles of CO2, and then use the molar mass of CO2 to get back to grams of CO2. So we will need the molar mass of propane, and we already have it. So it's 1 mole of propane is 44.11 grams of propane. We calculated that above. We need the molar mass of CO2. So let's calculate the molar mass of CO2. So for the molar mass of CO2, you take 1 time the mass of carbon, and that's 12.01 here. And then you take 2 times the molar mass of oxygen, and oxygen has a molar mass of 16.00 grams. You add that together and it's 44.01 grams per mole. So look, those numbers are very similar, but not the same, right? The decimals are different. So it's 44.01 grams per mole of CO2. And so when we rewrite this as equality, you know, it's 1 mole of CO2 is 44.01 grams of CO2. So that will allow us to do the first conversion and the last conversion. And for the middle conversion, that is the mole to mole conversion, we need to use the chemical equation coefficient and focus only with propane and carbon dioxide. And we can see that 1 mole of propane will allow us to produce 3 moles of oxygen of carbon dioxide, right? You take the 3 here and you slip moles in between, and then the 1 here implied and moles of propane. So mathematically, it looks like this: 1 mole of propane equals 3 moles of CO2. And then we are ready to do the calculation. We have our 3 equalities here. And so we will start the calculation with the same given amount as earlier, which is 28.0 grams of propane. So we have grams of propane in the numerator here, and we need to cancel that unit with the next conversion factor. So we want the grams of propane on the bottom, and we will use the molar mass of propane for that to change grams of propane to moles of propane. And so the grams, it's 44.11 grams of propane for 1 mole of propane. Right. So this way we are changing the grams of propane to moles of propane. Next, we need to change the moles of propane to moles of CO2, and we will use this equality. And so because we have moles of propane in the numerator in that first conversion factor, we need moles of propane in the denominator of the second conversion factor. And it's a 1 that comes with it. And then on top of that, it's going to be 3 moles of CO2. Okay, so that cancels the moles of propane as a unit. And in the next step, we need to cancel the moles of CO2 as a unit. So for the last conversion factor, we need the moles of CO2 in the denominator. And for this last step, we change moles of CO2 to grams of CO2. So it's going to be this molar mass of CO2 that we will use. And it's then for 1 mole of CO2, we have 44.01 grams of CO2. Oops. What? Okay, CO2. Okay, so in the calculator, we do 28.0 grams of propane times 3 moles of CO2 times 44.01 grams of CO2 and divided by 44.11 grams of propane. The calculator answer is this, so 83.8095 grams of CO2. So we need to pay attention to Sig Figs. Again, any kind of number of mole is an exact number, so these don't limit the number of Sig Figs. We have 4 Sig Figs in the molar masses and 3 Sig Figs in the given amount. So we need to keep 3 Sig Figs. So we keep the 3.8. What comes after the 8 is a 0, so we keep the 8. And then we have grams of CO2. That's the unit. And so that answers the question, calculate the number of grams of CO2 produced, and that's 83.8 grams of CO2. So let's move on to question 3 of the chapter 9 review. And it is similar to question 16 of your homework 9, which is the homework on chapter 9 in sapling. And so if you have difficulties in, solving question 16, then look at this example and it's very similar. So what is this example? How many grams of CaSO4 will be produced when 35 grams of aluminum sulfate is combined with 32 grams of calcium chloride? So that's the calcium sulfate here, and calcium chloride is CaCl2. Which reactant is in excess? And how many grams of the excess reactant will remain after the reaction is complete? So there is a lot of questions there, and we have to take one at a time. So first we will do the first question, and that will help answer the second question. So we have this a chemical equation. It's provided for you here, and it shows how aluminum sulfate reacts with calcium chloride to make aluminum chloride and calcium sulfate. So calcium sulfate is a product. So we are looking for how much product here is made. And so let me move here the initial values we have. We have the 32 grams of calcium chloride here, and then the 35 grams of aluminum sulfate here. So that's the two reactants, and we have different masses for each of them. But as you know, the masses don't tell you anything about, which one is limiting, because the molar mass of each compound can be quite different, and, and what matters is the number of moles. You need 1 mole of aluminum sulfate to react with 3 moles of calcium chloride. So that's what matters. So that's why we will need to convert each of these amount, separately. We will take these amount as the given amount, and we will change them into grams of calcium sulfate. And we'll see which one produces the least amount. And that's how we will answer which reactant is, the limiting one, and then which reactant is in excess. So that means you need to do 2 calculations. You need to determine how much product can be made from each reactant independently, right? So let's start with the aluminum sulfate. And it's okay. So the concept map is going to be looking like this. So let's see if I can move this up or not. No. Okay. It has to stay there because it's the second page. So we have the concept map will look like this. We'll have the grams of aluminum sulfate, and we'll convert them to moles of aluminum sulfate, right? So grams of aluminum sulfate to moles. And then from the moles, we will convert the moles of these to moles of calcium sulfate. right? It's a gram to gram stoichiometry calculation with moles of a reactant change into moles of a product in the middle. Okay, so I'd rather have this up there. Okay, so we will need the molar mass of aluminum sulfate, right? So let's look at the molar masses in the periodic table, because maybe you don't know these by heart. So we have aluminum. Aluminum is 26.98 grams per mole. There is oxygen, 16.00 grams per mole, and then sulfate, right? Sulfur is 32.07. So we need those numbers. So let's see here. You do 2 times the molar mass of aluminum. So 2 times 26.98 grams, right? Because there is 2 aluminiums per formula. Notice here how you have 3 sulfate, right? This whole thing is called the sulfate. And we have 3 sulfate. And there is only 1 sulfur per sulfate. So that means 3 sulfur atom per formula. So you do 3 times the molar mass of sulfur, 32.07 grams. And then you have 3 times 4, 12 oxygen per formula, because you have 3 sulfate and 4 oxygen per sulfate. So 3 times 4, 12 times the molar mass of oxygen. You add these up, and because all the molar masses are given with 2 decimals, you need to keep 2 decimals in the end. So it's 342.17 grams per mole of aluminum sulfate. Written as an equality, you know, mathematically, it's 1 mole of aluminum sulfate is equal to 342.17 grams of aluminum sulfate. So that will allow us to change the grams of aluminum sulfate to moles of aluminum sulfate. Let's find the molar mass for calcium sulfate. So calcium, let's find calcium in the periodic table here. We have calcium and it's 40.08. And then it's using also sulfur, 32.07, and oxygen, 16.00. So you do 1 time the molar mass of calcium, 40.08 grams. 1 time the molar mass of sulfur, 32.07 grams. And then 4 times the molar mass of oxygen, so 4 times 16 grams per mole. You add all of this up and it's 136.15 grams per mole of calcium sulfate. Written as an equality, or mathematically, it's 1 mole of calcium sulfate equals 136.15 grams of calcium sulfate. So we have our 2 molar masses. We need now the conversion factor or equality that will change the moles of aluminum sulfate to moles of calcium sulfate. And for this, we need to look at the chemical equation, and it's up there. And it's between this one. So 1 mole of aluminum sulfate produces 3 moles of calcium sulfate, right? The 3 is here in front of calcium sulfate. So mathematically, we write this like this. 1 mole of aluminum sulfate equals 3 moles of calcium sulfate. We have all our equalities, right? We need 3 of them, and we have them all. So we can start the calculation. Always start your calculations with the given amount. And here the given amount, remember, was 35 grams of aluminum sulfate. So we'll start the calculation with that. 35 grams of aluminum sulfate. This is in the numerator, even though here it looks like in the middle. It's actually in the numerator, and you could draw a line and then write a 1 in the denominator. So we need to cancel the given unit, right? The grams of aluminum sulfate need to be in the denominator of the conversion factor that comes after the given amount, so that we can cancel those units of grams of aluminum sulfate. And here at first we are changing grams of aluminum sulfate to moles, and we were using the molar mass of aluminum sulfate. So what comes with this unit is 342.17 grams of aluminum sulfate, and that's for 1 mole of aluminum sulfate. So that changes the grams to moles of aluminum sulfate. Next step, you want to change the moles of aluminum sulfate to moles of calcium sulfate. And here, because the moles of aluminum sulfate are in the numerator, we want them next in the denominator. So, and it happens to be a 1 associated with that. 1 mole of aluminum sulfate is making 3 moles of calcium chloride. So we need 3 moles of CaSO4 on top. Okay. So that changes moles of aluminum sulfate to moles of calcium sulfate. And in the third conversion factor, we need to cancel the units of moles of calcium sulfate. So they need to be in the denominator here. And for this, we are changing moles of calcium sulfate to grams of calcium sulfate. So we will use the molar mass of calcium sulfate. So that's for 1 mole there. Oops. 1 mole of calcium sulfate has a mass of 136.15 grams of calcium sulfate. Oops, let me change that. Yes, okay. That there, you know, it fills the whole width of the paper. So when you do this type of calculation, you really want to start on the left of your paper, because it's better to have everything in one line. Otherwise, it can lead to mistakes, you know, because here you really see how we can cancel units. And let me show that, how I can cancel grams of aluminum sulfate here. And then I can cancel moles of aluminum sulfate. And finally, I'm canceling moles of calcium sulfate here. So it's easier to see how you can cancel unit, because you know, you have one of the unit on top, the other on the bottom. So in the calculator, you do 35.0. I multiply all numerators together first. So times 3 moles of calcium sulfate times 136.15 grams of calcium sulfate. Divided, and there is only one denominator here worth typing. So divided by 342.17 grams of aluminum sulfate. The calculator answer is 41.7796, etc. And that's units of grams of calcium sulfate, right? The unit that is left over. So we need to pay attention to Sig Figs here. And we have, as always, all those mole numbers are exact. They do not limit the number of Sig Figs. We have 5 Sig Figs in the molar mass, 5 Sig Figs again in the other molar mass, and 3 Sig Figs only in the given amount. So we will need to keep 3 Sig Figs. So we will keep the 4, the 1, and the 7. What comes after the 7 is another 7. So the 7 needs to be rounded up to an 8. So it's going to be 41.8 grams of calcium sulfate. That can be made from 35 grams of aluminum sulfate. So that determines the amount of calcium sulfate that can be made from this first reactant. Assuming, of course, it is assuming that you have enough of the other reactant. We don't know yet which one is limiting. So now we want to do the other calculation, right? Because we've determined the mass of calcium sulfate from these 35 grams of aluminum sulfate. The next step is to do the same thing, but starting from the 32 grams of calcium chloride, and see which one will lead to less product. So let's move on then to the other one. Other calculation that starts with grams of calcium chloride this time. Again, we have grams, so we need to change them to moles. And then using the chemical equation, change the moles to moles of the product, calcium sulfate. And then go back to grams using the molar mass of calcium sulfate. So we need the molar mass of calcium chloride. So let's see how we calculate that. Let's go back to the periodic table to find the molar mass of chlorine. We have calcium, it's 40.08, and then chlorine is 35.45. So that's the new value here. So we have one calcium, so we take 1 time 40.08 grams of calcium per mole. And we have 2 chlorine, right? So we do 2 times the molar mass of chlorine, 35.45 grams per mole of chlorine. You add this up and it's 110.98 grams per mole of calcium chloride. Again, always keep 2 decimals if your given molar masses have 2 decimals. So written in mathematically in an equality, it's like this: 1 mole of calcium chloride is equal to 110.98 grams of calcium chloride. The other molar mass, we know it, right? It's the calcium sulfate, and we have it just above here, right? So it's just the same here. 1 mole of calcium sulfate is 136.15 grams of calcium sulfate. The last thing we need is the mole-to-mole conversion between calcium chloride and calcium sulfate. So let's look at the chemical equation for that. The chemical equation shows that 3 moles of calcium chloride are producing 3 moles of calcium sulfate. Even though it's 3 and 3, you need to show these 3s. You do not convert them to 1s. This is not proper, and we need to understand where it comes from. And so when you want to show your work, you keep the 3s. So that means it will be written as 3 moles of CaCl2 is equal to 3 moles of CaSO4, right? You want to keep the 3 to show where this comes from. It comes from the chemical, the balanced chemical equation. So we have our 3 equalities here. So we can start the calculation, and we always start the calculation with the given amount. And here the given amount was the 32 grams of calcium chloride. So let's start that. 32 grams of calcium chloride is the given amount for the calcium chloride. Because we have the unit of grams of calcium chloride in the numerator, we will need to have this unit in the denominator of the first conversion factor so that we can cancel units. And the first step is changing the grams of calcium chloride to moles of calcium chloride. So we will use the molar mass of calcium chloride, and what comes with the grams, it's 110.98 grams of calcium chloride for 1 mole of CaCl2. Okay, so that changes the grams of calcium chloride to moles of calcium chloride. And in the next step, we need to change the grams, the moles of calcium chloride to moles of calcium sulfate. And here we have moles of calcium chloride in the numerator, so we need that in the denominator in the next step. And the equality we are using now is the 3 moles of calcium chloride equals 3 moles of calcium sulfate. So this comes with the 3 moles of calcium chloride is equal to 3 moles of calcium sulfate. So SO, actually the O should be here. And that's a 4, SO4. 3 moles of calcium sulfate are made from 3 moles of calcium chloride, right? We need to show those 3s. Next, we need to cancel the units of moles of calcium sulfate, so they will need to be in the denominator of the next conversion factor. And that's the molar mass we need now, right? To change the moles of calcium sulfate to grams of calcium sulfate. So it's for 1 mole of calcium sulfate, we have 136.15 grams of calcium sulfate. There you go, you have the whole, the full calculation ready. And let's show how we cancel units. Here we cancel moles of calcium sulfate. Then we cancel the moles of calcium chloride. And earlier we canceled grams of calcium chloride. So now we are ready to do the calculation. And in the calculator, you do 32.0 times 3 moles of calcium sulfate times 136.15 grams of calcium sulfate and divided. So there is 2 denominators to use here. We have first divided by 110.98 and divided again by 3 because I don't use parentheses, so I need to use the divide sign again. Equals, the calculator answer is this, 39.2575, etc. And the unit is grams of calcium sulfate, right? It's the leftover unit here. And we need to pay attention to Sig Figs. As always, the mole number are exact. We have 5 Sig Figs in the molar mass, 5 Sig Figs in this other molar mass, 3 Sig Figs in the given amount. So we need to keep 3 Sig Figs. So 3, 9.2. What comes after the 2 is a 5. So we need to round the 2 up to a 3. So it's going to be 39.3 grams of calcium sulfate. And that's what can be made from the 32 grams of calcium chloride. So now we have the 2 amounts that can be made from each reactant separately. And now we can compare them. So we have the 41.8 grams of calcium sulfate from the aluminum sulfate, but only 39.3 grams of calcium sulfate from the 32 grams of calcium chloride. So what it tells you, the smaller amount of product that can be made is from CaCl2. So CaCl2 is your limiting reactant, right? So we can say that since the mass of calcium sulfate produced is smaller from the 32 grams of calcium chloride, then calcium chloride is the limiting reactant. And this mass, the 39.3 grams of calcium sulfate that will be produced, is called the theoretical yield, right? It's what theoretically you can produce. It's the maximum amount you can produce. But the question was asking for which reactant is in excess. So it was asking for the one in excess, not the limiting reactant. So if calcium chloride is the limiting reactant, then the other reactant is in excess. So then the reactant in excess is the aluminum sulfate, right? Aluminum sulfate will be left over. There will be some left over. And that's what the next question is about. How many grams of the excess reactant will remain after the reaction is complete, right? So we still have some calculation to do here. We know this is going to be in excess and you will have some leftover. So out of the 35 grams you have initially, there will be some leftover and we need to calculate that amount. So because the calcium chloride is limiting and it will completely react, right? So we will start with this amount, have it completely react and see how much of the calcium of the aluminum sulfate will be used. So we will do a very similar calculation, again, a gram to gram stoichiometry calculation, but between these 2 reactants this time, right? So the concept map will look like this. We'll do from grams of calcium chloride, we'll change them to moles of calcium chloride, change them to moles of aluminum sulfate, and then go back to grams of aluminum sulfate. And this way we will know how much of the aluminum sulfate has been used. So we will need the molar masses, and we have them already, right? The molar mass of calcium chloride is 110.98 grams. We also have the molar mass of aluminum sulfate, 342.17 grams. And then we need the mole to mole conversion factor here between the two reactants. And what it says here is that 1 mole of aluminum sulfate reacts with 3 moles of calcium chloride, right? We get this from this equation here, this balanced chemical equation. So we have everything we need now to do the calculation. So the starting amount, what will be the given amount you type first? It's going to be the mass of calcium chloride, right? That is limiting the amount that can react. So that's what you will start your calculation with. So we will start again with the 32 grams of calcium chloride. So we have units of grams of calcium chloride in the numerator. So we want them in the denominator of the first conversion factor, so we can cancel units. The first conversion factor uses the molar mass of calcium chloride, and what comes after with the units of grams, it's the 110.98 grams of calcium chloride, and that's for 1 mole of CaCl2. So that changes the grams of calcium chloride to moles. Next, we need to change the moles of calcium chloride to moles of aluminum sulfate, and we will use this equality. Because we have moles of calcium chloride in the numerator here, we want moles of calcium chloride in the denominator in the next conversion factor. And what comes with the moles of calcium chloride is a 3, from that coefficient there. And 3 moles of calcium chloride react with 1 mole of the aluminum. Let me grab this above. So the second conversion factor has the moles of aluminum sulfate in the numerator. So we need to cancel that unit in the last step. So moles of aluminum sulfate should be in the denominator of the third conversion factor. And in the third conversion, we are changing the moles of aluminum sulfate to grams of aluminum sulfate. So we will use the molar mass of aluminum sulfate. And so for 1 mole of aluminum sulfate, we have 342 grams, 0.17. And let's write down the unit here, grams. Okay. And that's ready. And please let me show how we cancel units. We cancel grams of calcium chloride. Next, we cancel moles of calcium chloride. And finally, we cancel moles of aluminum sulfate. And this way, we get grams of aluminum sulfate as the final unit. In the calculator, you do 32.0 times 342.17 divided by 110.98 grams of calcium chloride and divided by 3. And the calculator answer is, oh la la, hold on. So 32.887 grams of aluminum sulfate is the calculator answer, or at least part of it. So again, we need to pay attention to Sig Figs. All the mole numbers are exact and not limiting the number of Sig Figs. We have 5 Sig Figs in the molar mass, 5 other Sig Figs in the other molar mass, and 3 Sig Figs only in the given amount. So we need to keep 3. We need to keep the 32.8, but what comes after the 8 is another 8, so you need to round the 8 up to a 9. And so that's going to be rounded to 32.9 grams of aluminum sulfate. And that's what has reacted, right? Remember that we were calculating the mass of reactant that reacted with those 32 grams of calcium chloride. So of course it's less than the initial amount of aluminum sulfate, right? Because this is the reactant in excess. So to find the, to answer that question that is asking, you know, how many grams of the excess reactant will remain after the reaction is complete, we do the 35 grams that we had initially, minus the 32 grams, 32.9 grams that reacted. And so 35 grams minus 32.9, and that's 2.1, right? This is a subtraction, so you keep the least number of decimal places, and here they both have one decimal place, so you keep one decimal place in the end. And it's 2.1 grams of aluminum sulfate that is left over, because that's the reactant in excess. And so that answers this question here. And that ends the problem number 3.